Assalamualaikum. Today we will discuss IP security. Slides are from this book, Cryptography and Network Security, that you already have, chapter 20. First we will discuss the IP security overview. In 1994, Internet Architecture Board issued a report. The title of the report was Security in the Internet Architecture. This report was about to identify the main area for security mechanism, and they identify this thing that there is need to secure the network infrastructure from unauthorized monitoring and control of network traffic, and we need some secure end-to-end user traffic using authentication and encryption mechanism. So basically in this report it was identified that we need some mechanism which not only authenticate but also encrypt end-to-end user traffic that is going on the network. So in order to provide security, IAB, that is Internet Architecture Board, included authentication and encryption as a mandatory security feature in the coming generation of IP, which is actually IP version 6. So IP security is included as a mandatory feature in IP version 6, and it also have security capabilities which are designed to make it usable. Like IP security has this capability that it is not only used with IP version 6, but you can also use it with the current version of IP, which is IP version 4. As we have not already shifted to IP version 6, we are still there are systems present which are using IP version 4. So IP security or IPsec was initially proposed for IP version 6, but they said that we can also use it in IP version 4. It means that vendor can begin offering these features now, and there are many vendors which are now have some IPsec capabilities in their product. So the IPsec specification is now considered as a set of internet standards. So it is one of the standard IPsec. What are the application of IPsec, where we can use it? Now IPsec provides their services to secure communication on LAN, on private and public WAN, and on the internet. So you can use IPsec to secure communication. Mean we can authenticate and encrypt all our network data on LAN, on private and public WAN, and on internet. Okay, some of the example of its use include, like we have a secure branch office, okay, and we are connecting this branch office with each other through internet. So we have connectivity of different branch offices of a company using internet, because private network connectivity is more expensive. Internet connectivity is more economical, so that is a better option in term of economic cost. But in term of security, if you are connecting your company branch offices using internet, it means you are exposing your traffic on the internet to everyone. So there is a issue of security concerns. But if we are using IPsec, then we can securely connect our branch offices using internet, because we are implementing IPsec on it, and when we have IPsec on it, it means it is providing both authentication and confidentiality. Okay, second example includes secure remote access over the internet. It means that if you have an employee who is always traveling to different places, and he wants to connect with the company network also from the remote place, so that end user will have IP security protocol installed on their system, Then they can make a local call to ISPs and then gain secure access to company network. So it will reduce the cost of toll charges for traveling employee and telecommuters. Okay, third application is that IPsec can be used to secure communication with other organization. Like you can have extranet and intranet capability with partner. You can connect with them and it ensure both authentication and confidentiality on that connected network. Okay, another very interesting application of IPsec is it enhance e-commerce security. You know that when we are on the web, so on web and e-commerce application, we need to have a built-in security protocol. So the use of they already have a built-in security protocol, like you know when you are HTTPS and TLS. So along with this, if we want end-to-end security, then we can, if we are going to add IPsec with it, so the use of IPsec will enhance that security. So IPsec will guarantee that all traffic that is designated by the network administrator is both encrypted and authenticated. So it add an additional layer of security along with, you know, we already have a security at the application layer, but IPsec is adding an extra layer of security on the network layer. So IPsec protocol provides security on the network layer. So when we enable IPsec, it means all our traffic on the network layer is secure mean encrypted and properly authenticated. So you can support so IPsec, by using IPsec we can support various application, even that application do not have any built-in security feature into it, like you know we can have remote login, client server, email, file transfer, web access and so on. Any application without even having a security on application layer, if we enable security at the network layer, all these applications will be secured using IPsec. So IPsec is the protocol that provide end-to-end security on the network layer. Okay, this diagram show an IPsec VPN scenario. If you look at this network, we have a LAN over here on this side, another LAN over here on this side, and there is one independent user which is using a system with IPsec capabilities. Now we can see that this system can communicate to this network, to this system. If this is the source and this is the destination, this source can communicate with this destination on internet securely using IPsec. Now if you look at this diagram, this can be your firewall or your router which has IPsec capability into it, okay, which has IPsec enable on it. So we do not have a traffic here from this system. The traffic that is generated is a normal traffic, okay, unprotected IP traffic, this thin line. So unprotected IP traffic will move from here until it reaches to this router with IPsec. So this router will create a tunnel with the destination router over here on internet. Although internet is a public network, but we are creating a virtual private network on internet using IPsec. So this tunnel is created, okay, virtual tunnel protected IPsec is created from source to destination, and all the traffic, like if a packet is coming from your normal packet, it will be encapsulated into a new packet, and a new IP header will be inserted by this router, and this new IP header will have a source this and destination this instead of original source and destination. And when it is reached to the destination network will remove this new IP header, and after decrypting and properly authenticating this packet, will send the IP payload to the destination system by using unprotected IP traffic. So here we create a tunnel using IPsec, and where IPsec is, this is normal IP payload and original IP header, and here we include ESP header, which is IPsec header. Okay, more detail is will be coming in the next slide, so it will be more clear for you. Okay, some of the benefits of IPsec. First benefit is that, like in this previous network, if we implement IPsec on the routers, okay, like here we said that if IPsec is implemented in a firewall or router, then it will provide security for all the traffic. Like here internal system are generating the normal traffic, but whenever it cross this network, this LAN, when it goes on internet, all the traffic will be properly encrypted and authenticated. So this is the one benefit of IPsec, and there is no extra overhead for security related processing for the normal system on the company network. Like this system does not know anything about IPsec. It is generating normal traffic, so there is no any extra processing overhead on any of the network system except the edge router, which is connecting your network to the internet, and that router or firewall is only using IPsec, and all the traffic will be properly authenticated and encrypted. So this is the one of the benefit of using IPsec. Okay, IPsec, if we are implementing IPsec in a firewall, so it is resistant to bypass. How it is resistant to bypass? Because if all traffic from the outside must use IP and the firewall is the only the entrance point into the your network from internet, so each and every packet that is entering into your network must have to pass through this firewall or this router. So this firewall or router can add extra processing on it, like it can check whether a packet is like a spoofed IP address or some other DOS attack or any worm virus or Trojan horse is there. This device can filter the traffic based on your security policy of the organization. Okay, as I told you that IPsec is below the transport layer, it is on the network layer. Okay, so it is transparent to application and user. Application and users are not aware of any of the complexity on the for the encryption and authentication, and you don't have to make any change in your applications, okay, or software that you are using, because IPsec is implemented in the firewall or router, and that firewall or router will take care of all the IPsec related processing on the traffic. IPsec is can also be transparent to end user, because we are implementing it on the edge routers or firewalls, so there is no need to train your normal user to use IPsec, like how to issue keys or revoke keying material. Everything is transparent to end user, and we don't need to make any burden on the end users, and they are even unaware if there is any security or processing is being done on the traffic that they are generating from the network. Okay, another benefit of IPsec is it can provide security for an individual user if you need it. Like if we have some employee who is working from other remote location, so they can connect to the company network using internet through IPsec. As we have already mentioned in the benefit of IPsec, that it support end user and protect the premises system and network, but not only end user traffic, but also IPsec can play an important role in the routing architecture which is required for internet working. So what kind of services IPsec can apply to the routing? If it can make it, if we are using IPsec, it can assure that a router advertisement come from an authorized router. Like if an adversary or an attacker add a new router into the network and try to advertise like it's a valid route, it can easily be identified if we are using IPsec. to confirm that this router advertisement is coming from an authorized router or not. Similarly, neighbor advertisement come from an authorized router or not. We use a neighbor advertisement to establish or maintain a neighbor relationship with a router in another routing domain, so this can also be checked. Also, IPsec can use to make sure that a redirect message comes from the router to which the initial IP packet was sent, or a routing update is not a forced update message. So without such security measure, an opponent can easily disrupt communication or divert some traffic if we are not adding secure routing into our network. So routing protocol like OSPF should be run on top of security association between routers that are defined by IPsec, so that we can provide secure routing on our network. If we look at the specification of IPsec, IPsec consists of three main functional areas: authentication, confidentiality, and key management. And there are so many RFCs and draft IETF document where you can find the IPsec specification, and because there are a lot of documents are available, so it make it complex and difficult to understand these IETF specification in a proper way, or IPsec standard in a proper way. So the best way to understand the IPsec is to consult the latest version of IPsec document roadmap, which is written in this RFC 6071. Okay, now we will discuss IPsec's RFC 6071. So RFC 6071 can be categorized into the following group. First is the architecture. So architecture cover the overall general concept, security requirements and definitions and mechanisms that are defining IPsec technology. And then we have authentication header. Authentication header is an extension header to provide message authentication. Like when we are using IPsec, it has two main protocols. One is authentication header and other one is ESP. So authentication header only provide message authentication, and its specification you can find here in this RFC 4302. And ESP, as I told you, IPsec has two main protocol, AH and ESP, AH only provide authentication, ESP provide both authentication and encryption. So it consists of an encapsulating header and trailer used to provide both encryption combined with authentication. So you can have two options in ESP. You can use it for encryption only, or you can use it for encryption plus authentication both. And the current specification that describe this ESP is RFC 4303. And as I told you, IPsec has three functional areas: authentication, confidentiality, and key management. So AH is related to authentication, ESP is related to authentication and confidentiality, and IKE, Internet Key Exchange, is related to key management. So for key management, the main protocol used by IPsec is called IKE protocol, or Internet Key Exchange protocol. Its main specification is given in this RFC 7296. Okay, for cryptographic algorithm, this category consists of a lot of documents which define the cryptographic algorithm that are used in IPsec for encryption, message authentication, and pseudo random function, and cryptographic key exchange function. So all the cryptographic algorithm that are supported by IPsec are specified here in cryptographic algorithm. And then there are some other documents available there which include things like dealing with security policy and management information based content. As I already mentioned previously that IPsec provides security at the network layer or at the IP layer. We use IPsec protocol on top of IP protocol, whether it is IP version 4 or IP version 6. So IPsec provides security at the network layer or IP layer, and it allow a system to select different things. First is you have to select the required security protocol. We have two protocols, one is AH and another one is ESP. So you can choose what you want. If you want authentication, you can choose AH or ESP, any one out of it. Okay. If you want confidentiality, then you have to choose ESP. So you have, as per your requirement, you have to choose first security protocol. Then after choosing the protocol, you have to determine the cryptographic algorithm that are going to use for that service. Like, okay, if you choose encryption, so in order to encrypt your data, which algorithm you are going to use, you have option like you can use AES algorithm or some other algorithm, okay, to encrypt your data. Which mode of operation will you use, okay. So you have to determine the algorithm that you have to use to provide the service in the chosen security protocol. And third thing, okay, everything in cryptography or every algorithm in cryptography need keys. So how to now share the keys among parties to perform that or to run that security protocol. So third thing is you have to choose, you know, mechanism to share cryptographic keys with each other. Okay, so RFC 4301 list the services that are mentioned over here, like access control, connectionless integrity, data origin authentication, rejection of replayed packet, confidentiality, limited traffic flow confidentiality. So based on your security service, you can choose the protocol, which protocol you need, whether AH or ESP. As I already told you, which protocol you use, you need to provide the services like these confidentiality, limited traffic flow confidentiality. As I already mentioned that IPsec have two protocols to provide confidentiality and authentication, which are AH and ESP. And both AH and ESP support two modes of use. You can use them in either one of these modes. One is transport mode and other one is tunnel mode. The transport mode provides security for the upper layer protocol like TCP, UDP or ICMP packets. Okay, and when to use transport mode? Transport mode is used for end-to-end communication between two hosts, and if both hosts are having the capability of IPsec and you want to have end-to-end communication secure between them, then you should use transport mode. If we are using transport mode with ESP, then ESP in transport mode will encrypt and optionally authenticate the IP payload, but not the IP header. Okay, so this is something note down. If we are using ESP in transport mode, it will only encrypt payload, IP payload. IP header will not be encrypted by ESP in transport mode, and authentication is optional over there. If you want to use it, okay, it will, you can add it. If you are using AH in transport mode, as we know that AH only provide authentication, so AH in transport mode will provide the authentication of the IP payload and some of the fields of the IP header, not the complete IP header, but some of the field of the IP header will be included in authentication. On the other hand, if you are using tunnel mode, now tunnel mode means that you are encapsulating your packet, your original IP packet, into a new IP packet, and you are adding new IP header with it. Okay, so it provides protection to the complete original IP packet, because original IP packet is encapsulated into a new IP packet. Okay, we are creating a tunnel like in a virtual private network. So it provides protection for the entire IP packet. When we use tunnel mode, okay, tunnel mode is used when one or both end of security association are security gateways. What are security gateways? Your firewall or routers enabled with IPsec. So if you have your router or firewall enabled with IPsec, so they both will communicate using tunnel mode. But if you have a host, normal host, both enabled with IPsec, then you should use transport mode. Okay, so tunnel mode is also used in case when one end is gateway, like here, this slide. If we want to communicate between this and this firewall or router or networking device with IPsec, they will create a tunnel. So tunnel mode is appropriate. Or if we have one end as a firewall or router, like here, this user on the system want to communicate into this network, so they will create tunnel. Like one end is a router or a firewall and the other end is a normal user system with IPsec, so they use tunnel mode. Okay, when is transport mode is good to use? When, like here, we have one user or system with IPsec and we have let's suppose here another user that is having IPsec enabled, and they both want to communicate with each other, then transport mode, they will use transport mode. Okay, and when is tunnel mode? Here, when both end are security gateways, tunnel mode, or when one end is security gateway, so you should use tunnel mode. So when we are using tunnel mode, then all the nodes or hosts which are behind that firewall or router, they are communicating securely with other system on the internet or in other network using IPsec, but they are not aware of it. Okay, so if we are using ESP in tunnel mode, it will encrypt and optionally authenticate the entire inner IP packet, including IP header plus payload. So ESP in tunnel mode can encrypt complete inner IP packet, include IP payload and header. Okay, but if we are using ESP in transport mode, then it can only encrypt and optionally authenticate IP payload but not IP header. But if you want to protect header as well, so we should use tunnel mode. Same as in AH, in tunnel mode authenticate the entire IP packet and selected portion of the outer IP header as well. Okay, this table gives us the comparison of again same thing like transport mode and tunnel mode. If we are using AH in transport mode, AH only provide authentication, so it will only authenticate IP payload and some portion of IP header and IP version 6 header. If you are using IP version 4, then selected portion of IP version 4 header, and if we are using in IP version 6, also some portion of IP version 6 and IP version 6 extension header. But if we are using AH in tunnel mode, then it will authenticate complete inner packet including header and payload plus some portion of the outer IP header, because in tunnel mode we encapsulate the original IP packet into a new IP packet. Like I will show you, if we are using tunnel mode, this is your original packet, original IP packet. So this original packet is encapsulated into a new packet with new header. Here we add new header. So if we are using tunnel mode, so everything is encrypted, authenticated. All original IP packet including header and payload plus portion of new IP header, some fields of new IP header. Okay, this figure gives you better idea how we can use AH in transport mode and tunnel mode. Like here we can see this is original IP packet. Original IP packet consists of data and IP header. Okay, here in this data we have TCP header and application layer data, so we just ignore it, just assume we have data and IP header. Now when we are using AH in transport mode, AH header is inserted in between original IP header and data. Okay, here we insert this AH header, a new header. Okay, and now how many, because AH only provide authentication, so what will be authenticated when we are using AH? Your whole data is authenticated and some of the field of IP header. All the, which field are not included in authentication? Mutable fields. Okay, what are the mutable fields in IP header? Checksum, because checksum is a mutable field, and other one is time to live field, because you know TTL field, every time when your packet move from one hop to next hop, it is decremented by 1. So this is mutable field, and when TTL field is changed, so checksum also need to be recalculated. So these mutable fields are not included in authentication, except every entire data, and some field of IP header are included which are not mutable in authentication. Okay, this is transport mode. Now in tunnel mode. In tunnel mode, this is your original packet. Okay, this is your original packet. You insert this original packet into a new packet. This is a new packet that you create, and in this new packet you have a new IP header, and in between new IP header and old IP header or original IP header we insert authentication header in tunnel mode. You can compare both. In transport mode, AH is inserted between original IP header and data, but in tunnel mode your original IP packet is encapsulated into a new IP packet with a new IP header, and AH is inserted between new IP header and original IP header. And what is included in authentication? Everything is included in authentication from here to here. Now all the field of original IP header is included in authentication, and for new IP header all those fields are included in authentication which are not changeable or mutable. Okay, okay, now look at ESP in transport and tunnel mode. So let's suppose here we show a original IP packet, and this original IP packet is like we have original IP header, then this is the data part, and data part is TCP header, application layer data, and if we use any extension header like in IP version 6, if we are using extension header, then that extension header is there. Okay, now if we are using ESP in transport mode, where your ESP header will be inserted, your ESP header will be inserted same like in AH in transport mode with original header. This is your original header and data. So ESP header is inserted in between the original header and data field. Okay, now what is encrypted and what is authenticated? As I told you, you can use ESP only for encryption. If you are using it only for encryption, then your, okay, another thing with ESP not only add header but also add this trailer. Okay, and ESP authentication data. So here in this packet will be modified like this. It will be included with ESP header, ESP trailer, and ESP authentication. Okay, now which fields are covered in encryption? Your original data is all encrypted along with ESP trailer. And what is if we are using ESP with authentication, then your ESP header is also authenticated, and ESP trailer and all authentic and data, and this authentication information is stored over here in ESP or authentication field. Okay, if we are using ESP in tunnel mode, so same is in tunnel mode, this is your original packet. Okay, you include your original packet or encapsulate it into a new packet. Okay, new packet have its own new IP header, and if there is any extension headers, so ESP header is inserted between the new IP header and the original IP header. Okay, ESP header is over there, trailer and authentication is like previously, you know, in the end. first trailer and then authentication. So if we are using ESP for encryption only, then which information is encrypted? All your original packet and ESP trailer information is encrypted. And what is covered with authentication? Your all original IP packet and your ESP header is authenticated. So if we look at the authentication of AH and ESP, AH also provide authentication of the some of the fields of the IP header, but ESP, no, it does not provide authentication of any of the field of the IP header, this new IP header or this original IP header. Okay, now next thing is like we have decided about whether we are using AH or ESP. Okay, AH or ESP, internal mode or transport mode, whatever you have decided. Now whatever you have chosen, but the fundamental to the operation of IPsec is that the concept of security policy to the packets that are transmitting from source to destination. So IPsec policy is needed for that, like what is going to be applied on each packet, and IPsec policy is specified in two databases, SPD and SAD, security policy database and security association database. So if these are two host source, let's suppose host A and host B, so in both host A and host B, if IPsec is enabled, then they have to have a record of SPD, SAD, okay, their own side. And what IKE protocol is needed to perform key exchange first. So first they need to establish like keys on both sides, and once keys has been established, then they can use those keys to encrypt or authenticate their IPsec traffic on that link. Okay, security association is a very important concept with respect to IPsec. So security association, we can define it as a one-way logical connection between a sender and receiver that are using security services of IPsec on the traffic that is carried on that connection. And if we want that from sender to receiver and receiver to sender, like two-way traffic, both to be secure, if we want two-way secure traffic on that connection, then we will need two security association. Very important. Security association is a one-way logical connection. So if you need two-way secure exchange, then you will need two security association on a particular connection. Now in as I showed you here, we have a security association database. Okay, this database keep record of all the security association that are carried on this node or this host. Okay, this database, you know, we have a database. In this database, how can we identify a unique record in this database, or like security association database table? So a unique record is identified by two fields of the packet which is received. One is IP version 4 or IP version 6 destination address. You know, your IP packet have source IP and destination IP. So one thing that is used as a primary key of the security association database is IP destination address, not the source, IP destination address. Another thing is SPI. SPI is what? Security parameter index. This SPI information is there in AH or ESP header. Destination IP address is from IP header and SPI information from AH or ESP header. So both these fields uniquely identify a particular record in the security association database. Okay. Now we will discuss them each one by one. Third field also, security parameter index plus which is the protocol, which security protocol, AH or ESP. Three things are there. So security association are uniquely identified by three parameters. First is security parameter index. Security parameter index is present in AH or ESP header. What it is? It is a 32-bit unsigned integer number. Okay, whenever a new security association is established, a unique 32-bit integer unsigned positive integer is generated for it, and it is carried in AH or ESP header. Then we have IP destination address. This is the address of the destination endpoint of the security association, and endpoint can be a end user system or some firewall or router, it depends. And security protocol identifier, which identify whether this security association is related to AH or ESP protocol, which protocol is being used on this security association. Another important thing is, on one security association you can either use AH or ESP, but not both together. So if you want to use both AH and ESP on a single connection, so you will need two security association on one way, and if two way, then you will need four security associations in that case. So in each IPsec implementation there is a security association database which define the parameters associated with each security association, and each security association is defined by following parameters in security association database entry. SPI, security parameter index, as I already explained to you, it is a 32-bit unsigned integer which is selected by the receiving end of an assay to uniquely identify a security association. Note this SPI has two functions. First is for outbound security association. Outbound security association, like if on security association a traffic is going to the outside of the network. Okay, so this SPI is used to create the packet AH or ESP header, because we need to include SPI in AH or ESP header. And in an SAD entry for an inbound assay, if you receive a traffic on security association, then SPI is used to map the traffic to a particular assay. Then we have sequence number counter. Again, sequence number counter is a 32-bit value which is used to generate the sequence number field in AH or ESP header. So AH or ESP header have a sequence number field, and every new packet a new sequence number is generated. Sequence number prevent replay attack, because every new packet will have a different sequence number. Sequence counter overflow, it is a flag. Flag mean a 1-bit value which tells you whether overflow of sequence number should generate an auditable event and prevent further transmission of packet on this assay. Like, you know, we have a 32-bit value, so if you can have on one security association maximum you can send 2 raised to the power 32 packets on it. So if it has reached to the end, so we will not reinitialize to 0, but we have to generate this sequence counter overflow error, and we might have to finish this security association and create a new security association as a result. Anti-replay window. Anti-replay window is used to determine whether an inbound AH or ESP packet is a replay packet. AH information, that is authentication algorithm, keys, key lifetime, and related parameter being used with authentication header. That information is stored in AH information, and in ESP information all the encryption and authentication algorithm, the keys, IVs, what is the lifetime of key, all these parameters are stored in ESP information field. Lifetime of this security association, this is a time interval or a byte count after which security association will be expired and need to replace with a new security association or with a new SPI. And IP protocol mode, IP protocol mode specify that which mode is being used, like transport or tunnel. Path MTU mean maximum transmission unit. So that is a maximum size of packet that can be transmitted on this network without fragmentation that is specified in path MTU field. Okay, security policy database define which traffic to be protected, how it is to be protected, and with whom to protect it. So the sending host determine what policy is appropriate for the packet, like for outbound traffic, depending on different selectors by checking those selector in the security policy database. So security policy database contain entries, okay, record or entries, each of which define a subset of IP traffic and different points to the security association for that traffic. And if we have a more like complex environment, so there may be multiple entries that possibly relate to a single SA, or multiple security association that are associated with a single SPD entry. Okay, now each SPD entry is defined by some parameter. What are those parameter? A set of IP and upper layer protocol field values, IP and upper layer protocol like TCP or UDP field values, and these are called selectors. Okay, so in effect these selectors are used to filter outgoing traffic so that we can map it into a particular SA. Okay, these are the selector which determine SPD entry. A remote IP address, which can be a single IP address, or an enumerated list or range of addresses, or a wildcard address. So or local IP address. Local IP address may be a single or enumerated or range of address. So same, we can have a remote IP address or local IP address. If we have enumerated list or range of address, then it required to support more than one source system sharing the same SA. Like on one security association, we have more than one source systems. And a remote IP address, in case of we have enumerated list or range of address, it means it support more than one destination system sharing the same SA. So this is the difference. On remote, if we have enumerated list or wildcard address, it means it support more than one address system sharing the same SA. And in case of local IP address, if this is the case, it support more than one source system sharing the same SA. Other SPD entries include next layer protocol, like after IP header, whatever header is, which protocol is being used, like you can have AH or ESP, whatever next layer protocol. And after IP, like we can have TCP, UDP. So next layer protocol is a field in IP version 4 which specify like which is the next header. Most of the time it is TCP or UDP. Then we have a name. Name is a user identifier from the operating system. This is not the field in IP or upper layer header, but it is available in if IPsec is running on the same operating system as the user. And then we have local and remote port that are individual TCP or UDP port values, or maybe enumerated list of ports or wildcard ports. Okay, here is an example. SPD is given, and if you look at the selectors, we have protocol, local IP port, remote IP port, action and comment. These entries in this SPD are self-explanatory, like we can say UDP port 500 is designated port for the IKE. So any traffic from the local host to the remote host for purpose of an IKE exchange bypass, action is bypass the IPsec processing, and so on. Okay, this flow chart represent the main element of IP processing for outbound traffic. Now which traffic is outbound traffic? The traffic that is going outside of your network. Okay, so we assume that uh, we receive our data from a higher layer like TCP or UDP to the network layer. Okay, and IP packet is created out of it. Now this IP packet consists of an IP header and IP body. Okay, so now what are the steps that will be followed? First step is uh, IPsec will search for SPD entry for a match to this packet. Okay, there are two possibilities: match found, match not found. Okay, if no match is found, then the packet is discarded and error message will be generated. Okay, in the other case, if match is found, then it will look for the uh, policy in the SPD database. And if okay, we have three possibilities for the policy. Okay, it will determine the policy in SPD database. So as per policy, if it is discard simple, a packet will be discarded, but other two policies can be bypass and protect. Okay, if the policy is bypass, then there is no further IPsec processing on it, and the packet is forwarded to the network for transmission. Forward packet via IP for transmission, no further processing. But if the policy is protect, it means that we need to perform IPsec processing on this packet. So then in that case, there is a search made for security association database for a matching entry. If now when they search for security association database, there are two possibilities: match found, match not found. If no entry is found, then IKE is invoked. So we have to create a new security association with appropriate IKEs, and entry is made into security association database after IKE. Okay, if no match, then IKE will be called, and then a new entry will be added into security association database after that. Okay, in case if match found, then the matching entry in SAD will determine the processing of this packet, like whether we are going to just encrypt it or authenticate it, or we have to do both encrypt and authenticate, which mode is going to be used, which cryptographic algorithm is to be used. So based on that, we will process this packet, create like update the packet, IP packet, as per protocol mode and algorithm, and then forward this packet for a transmission on the network. Okay, this figure is representing the main elements for IP processing for inbound traffic. Inbound traffic, like you receive your firewall, a router or a host receive a packet from internet. Now how to process this packet? Okay, so first thing is we have to determine the type of the packet, whether this is a normal IP packet or IPsec packet. So if it is a normal IP packet, then we will search for security policy database, uh, and if the first match entry in security policy database for this normal or unsecured IP packet is bypass, then the IP header is processed and removed off, and the packet body is delivered to the next higher layer over here, like for TCP or UDP. But if the matching entry has a policy of protect or discard, then there is no matching entry, so the packet will be discarded. Not bypass, then it will be discarded, but if bypass, then it will be delivered to the next higher layer for processing. Okay, but if the packet type is IPsec, then again we will search the security association database. IPsec will search for SAD, and if no match is found, the packet will be discarded. But if match will be found, then IPsec applies whatever appropriate ESP or AH processing on it, then IP header is processed and removed off, and the packet is then delivered to the upper layer such as TCP or UDP.